So most of you know my work from language, and it's time for updates. So there is a new passion in the Red Lab. It's called statistical learning, and the upshot of it that humans and all other animals are constantly bombarded by continuous streams of sensory information. And statistical learning is this mechanism, a general mechanism, by which cognitive systems, either in humans or animals, extract irregularities from the environment. This is done across time and space to discover the structure or the underlying structure of the input. And therefore, it's a major capacity because it plays a key role in discrimination, in categorization, segmentation of information. And this is what allows us to predict upcoming events and a wide range of many cognitive abilities. Now, it's a remarkable ability in the sense that we are very sensitive to very subtle differences in transitional probabilities between items in the inputs. We're very sensitive to frequency of co-occurrence in times, and this is done and can be shown with various species from humans to songbirds. The input can be either auditory or visual or tactile. The content can be verbal or non-verbal. It doesn't require at all overt attention. It can be completely without it. And this capacity is present very young. So actually you can see it in newborns that are 1 to 3 days old. So the question is, why would a word nerd like myself study that studied visual word recognition for 2 decades would be interested in statistical learning? And the reason is that language is really a highly structured statistical environment. We know that spoken words in a language are characterized by patterns of transitional probabilities. These constraints the structure specific to any given language. We know in the same way that every writing system is characterized by some correlations between spelling and sounds and between letter sequences. And this is characteristic to different writing systems. And every language has correlations between some patterns of phonological patterns or orthographic patterns in between meaning. This is what we call morphology, like prefixes and suffixes. So anyway, this is another way of looking at language, really as a set of correlations that we need to pick up from the environment. So I got really interested in first and second language learning and statistical learning recently. And we know that regarding second language learning, proficient readers would develop sensitivities to the statistical properties of the language and the writing system. And while learning to read in L2, they would acquire a new lexical system, mainly by picking up on the new set of correlations that are characterized there. And like any cognitive ability, there are some individual differences. And this is the focus of the work in our lab recently. The usual suspects doing this are sitting there, Noam, Louisa, and also Henry. And the big question that we are asking is whether this ability to pick up regularities or this sensitivity to small patterns of correlations in the environment predict the ease or difficulty in learning to read. How do we measure it? So I'm going to show you a few of the tasks that we are amusing ourselves recently to develop to test this ability. So this is a typical visual statistical learning task. You have here 24 shapes. They are constructed in a continuous stream by triplets. In some of the triplets, the shapes, as you can see here on the left side, are completely predicted. There is a probability of 1 of the second shape to appear after the first, of the third shape to appear after the second. And then subjects simply watch for 10 minutes this familiarization stream, and then we ask them questions about the rules regarding the transitional probabilities in the stream. And basically it looks like this. You would see it, and you see this for 10 minutes if you don't fall asleep. After you've seen that, we would ask you which triplet belongs to the sequence. Is it this one or this one? This is a typical task. Now, we can do it auditorily. It would sound like this. And then again, you would face a questionnaire, which triplet belongs to the sequence, this one, or this. It's not this one, but I'll give you another type of, we are really very creative in creating this, because if you want to omit the verbal aspects of it, you can hear this type of a string. Much more difficult task. And recently, very, very creatively, we have this one. These are sounds that are perhaps more familiar. No, no, no. This one. Okay. These are the types of things that we do to amuse ourselves in the lab. So what did we discover regarding this statistical learning ability? First, there is substantial variance in performance across individuals. We have here how performance looks like in the visual statistical learning task and the auditory one. And you can see there is a very, very wide range of performance. Subject can be very low or really above, almost fully correct in the questions that we ask at the end of the session. Strikingly, it's a very stable capacity of the individual. So if you ask subject to come again a few months later on and do the same test again, what you see here, that their performance is really stable. So the test-to-test reliability here is about 0.6, sometimes even more. So subjects who are good at this, at a certain point, they are going to be good at that again later on. And subjects who are hopeless at it, I'm not going to mention names here because some of them sit here in the crowd, like in Bal. They are not good at it. No.
Across modalities too? Across modalities too? If you're good, what are you good in the other?
This is a very interesting question. I'll get to it. Since I'm mentioning BAL, I want to make it clear that it is not nested in other cognitive ability. So there are very low correlations between this ability and like general intelligence or working memory. So it's really an ability on its own. Here are the correlations of visual statistical learning and visual working memory, digit span, Raven's advanced matrix, switch task, syntactic processing. Correlations are very, very low. Same with auditory statistical learning. So it's not intelligence here at all. Back to language. So how is it related to language learning? So here we had, for example, this is a typical study, 27 English native speakers coming to the school of overseas students to learn Hebrew. We tested them twice during the year, in the first semester and the second semester. And we had 3 independent measures of learning to read in Hebrew: non-word decoding, speed, and errors. And basically, each subject got an individual learning score. His Z-score at the second semester minus the first semester, showing you how much he has improved. There is an accuracy in reading unpointed words in Hebrew. Again, the same type of score. And cross-modal morphological root priming. This is how you're sensitive to the root structure of Hebrew, part of learning to read in Hebrew. And we have the priming effect here. What we find is 1 minute. Striking correlations, actually 0.57 between the score in the visual statistical learning task and non-word decoding, 0.44 morphological priming, 0.43 in naming. So in 10 minutes test, you come to the lab, and we can predict with high accuracy how you're going to be doing at the end of your year learning Hebrew. This is a replication we did with our colleagues in Taiwan. All these people come to learn Chinese in Taiwan. And this is the prediction on how many Chinese characters they will learn at the end of the year, given the score in VSA. So these are the current research questions we have in the lab. We ask what determines statistical learning performance for a given individual in a given task. We're interested in that. What are the theoretical dimensions of this capacity? It's not enough to say that it's not nested in other abilities. The question is what underlies it. Can you track behaviorally, neurobiologically, the process of perceiving dysregularity? This is done right now with Louisa and Ayelet's lab. What exactly drive this correlation between task and reading performance? And what are the neurobiological and shared mechanisms of statistical learning and language learning? Thank you.
Very quick question.
Maya, there is no correlation between the visual and auditory unless some conditions are met. I will tell you about them later, but it's an interesting question.